Welcome. In the next few minutes, I'm going to make a few suggestions to help you pick the best LadyBug power sensor for your application. Frequency range is one of the most important aspects in selecting a power sensor. Power sensors are not frequency selective. They measure all of the power applied inside their frequency range. You'll want to pick a power sensor that has a greater frequency coverage than the measurement you're making. Don't forget to consider the requirements of future applications. We manufacture three types of USB power sensors. General purpose true RMS average sensors. These are great for most applications. We manufacture peak and pulse sensors that directly measure pulse power on a modulated signal. And then we manufacture pulse profiling sensors that add a time-domain plot like you might see in an oscilloscope. Now let's take a quick look at the difference between our true RMS sensors and our peak and pulse sensors. Both sensor types are thermally stable and use our patented no zero, no cal before use technology. The true RMS sensors are great for communication signals. They're accurate with any signal with any modulation. So if you've got a 42 gigahertz communication signal with a 400 megahertz modulation, you're going to get an accurate measurement. They're great for general purposes. They're much faster than thermal sensors, and they're much more sensitive than thermal sensors. You can measure down to minus 60 dBm up to plus 26 dBm with one of these sensors. We offer them in a broad selection of frequency coverages, 1 megahertz to 8 gigahertz, 12, 18, 26, 40, and 44 gigahertz in one sensor. You can also get optional 9 kilohertz capability, so you can measure 9 kilohertz to 44 gigahertz without changing a sensor. This is great for source calibration. We also offer security options for defense users. So you can order option mil where you can't store data in the sensor, or you can order option SAN where you can securely erase the data that you stored in the sensor. Now all of our sensors, our true RMS sensors and our peak and pulse sensors, are ATE friendly. We offer driver support on those sensors. With our pulse and pulse profiling sensors, you can make statistical pulse measurements. Just start measuring. No gates, no setup, no triggering. Just start measuring and it'll capture the peak power, the pulse power, and the duty cycle for you. It's great for ATE systems. It makes direct pulse measurements. The measurements for this sensor are exceptionally fast, 2,000 settled measurements per second at full sensitivity, minus 60 dBm. It makes it great for antenna testing and other source testing where you have a CW signal and you just want to get a quick calibration point. Works very well for that. The pulse profiling software adds a time domain plot. It's important to understand all the specifications of the peak and pulse power sensor you're considering. Most competitive wide bandwidth pulse sensors trade sensitivity for bandwidth. They may advertise minus 60 or minus 70 dBm. However, they can only do that in average mode. When you put the sensor in pulse mode, the video filter opens up, allows noise in, which brings the noise floor up to minus 35 or so dBm in the pulse mode. Our sensors measure minus 60 dBm in pulse mode. So if you have a signal that has a modulation bandwidth of 10 megahertz or so, you can use one of our sensors and get a great pulse measurement. You can also use the sensor for making very fast average power measurements. So if you're testing an antenna or you're testing a source and you need a lot of measurements, you can make 2,000 settled measurements per second with any of our pulse sensors. Here's a small table that may help you select a sensor. On the top are signal types. In the middle is a row of measurement types and then a list of the 3 sensor types. Now I'm going to demonstrate some of our sensors and software. This is PMA12. It's a software that you use with any LB5900 series power sensor. Notice the plot at the bottom. It's not a pulse profiling plot, it's just a strip chart. Notice that I turn the power on and off and it responds very quickly. This display in this software is just about as fast as you need unless you're using a sensor programmatically. This is the power meter for our pulse sensors. It measures average power until it's placed in pulse mode by clicking this button. Once in pulse mode, the peak power, pulse power, duty cycle, and crest factor, and average power are displayed. When I change my signal from CW to pulse, you notice the duty cycle changes and the average power changes. The peak and pulse power remain the same because there's very little overshoot or droop on my signal. Remember, this is a non-triggered pulse measurement. This is the pulse profiling software for the LB480A and LB680A power sensors. Note that you can change the timing, you can add gates and markers and things like that. I just don't have time to show it to you here. It is available on our website, so contact us if you have other questions. Thank you for watching.